Good afternoon. This is a class on fluid mechanics. Here today I am going to start a new chapter which is called fluid statics. Here in this chapter you will find use of Archemedes law, use of Pascal's law. You will study also theoretical proof of Pascal's law here. Then you will learn something about manometers, means pressure measuring devices, etc. So in this video lecture I am going to discuss only something about Archimedes law. This law you have studied in class 7 or 8, like that. So, law remains the same. Statement of the law is same. There is no difference here. Here you will use that law to solve some problems on fluid statics. You know that when a body is immersed in fluid, the fluid may be liquid, it may be gas also. When a body is immersed in fluid, whether partially or fully, the weight of the body reduces to some extent. Few of you have some practical experience about this. Say, I am starting to discuss this theory with a problem. For example, we are taking a wooden log, the stem of a tree, okay, stem of a tree, wooden log. Say that is cylindrical. The cross-sectional area is circular, it has a length. Cross-sectional, say diameter is D, length is L. So it is like a right circular cylinder. And you know that the wooden log will not be fully immersed in water. Say for example, we are taking here water as the fluid. Okay, it will not be fully immersed. Some portion of the wooden log will be beneath the free surface of water, and some portion will be above the free surface of water. This is known to you. Most of you have seen this. So, first of all, the question arises why this wooden log is not going to the bottom of the water reservoir. Why not it is going to the bottom? Why it is floating? The answer is that when it is floating, it has no weight. Yes, when it is floating, it has no weight. What is the meaning of this? It has no weight. You know that. It has no weight. Actually, I want to mean that there is no resultant force acting in the downward direction when it is floating. It has weight, no doubt that it has weight. But apparently, we can say that there is no weight. It is weightless. So, what is happening when it is flowing, not flowing, it is floating in water? Weight of the wooden log is acting in the vertically downward direction. Still it is not going to the bottom. That means there must be some force which is acting in the vertically upward direction. and both the forces must be same in magnitudes. This is why there is no resultant force acting on the wooden log, and hence it is floating. It is not going to the bottom. If you push the wooden log from top, okay, if you push the wooden log from top, means you are trying to move the wooden log inside the water reservoir. What will happen? It will go in the downward direction, and as soon as you remove your hands by which you were pushing the wooden log, what will happen? It will again go up. It will again go up. So what is the reason behind this? Reason is that whenever you are pushing, it is going inside the water. So as soon as it is going inside the water, some force immediately starts acting in the upward direction. And as soon as you are removing your hands, the upward forces cause the wooden log to move in the upward direction. So what is the change? When it is floating, this is one situation. When you are pushing it inside the water, situation changes. What changes are there? Whenever you are pushing the wooden log inside the water, more water is replaced by the wooden log. Am I right? More water due to the volume of the wooden log. More water is being removed, is being not removed, displaced. It's better to say displaced. More water is being displaced by the wooden log. And that weight of the water, that extra water that has been displaced, acts in the upward direction. That force is called buoyant force, force of buoyancy, or buoyant force. So due to that buoyant force, it goes in the upward direction. And whenever it is in static condition, wooden log is partially submerged in the liquid. And it is in static condition. There is no movement of the wooden log. In that case, weight of the water in the downward direction is equal to the buoyant force in the upward direction. Buoyant force is how much? It is equal to the weight. It is equal to the weight. This thing always keep in your mind. Buoyant force must be equal to the weight of the wooden log, here in this case. Okay? So according to Archemedes Principle, when the wooden log is in water, some portion of the wooden log is beneath the free surface of water. So that portion of the wooden log has some volume which is beneath the water. That volume of liquid has been displaced by the wooden log. So that you calculate the mass of that. First you calculate the volume of that wooden log which is beneath the water. Okay, first calculate that. Now you calculate mass of liquid equal to the volume of displaced liquid, which is equal to the volume of the wooden log, which is beneath the liquid surface. Say for example, density of the liquid is rho. Density of the liquid is rho. Volume of the wooden log, which is beneath the free surface of water, is V. Then mass of liquid which has been displaced by the wooden log is equal to rho into V. That is the mass. Then what is the weight of that displaced liquid? It is equal to rho V into G. G means acceleration due to gravity. Mass into G. That is the weight. That weight is equal to the weight of the wooden log. What is the weight of the wooden log? I have already said that diameter of the wooden log is D, length is L. So what is the volume? It is pi by 4 d square multiplied by L. Pi by 4 d square L, that is the volume. Say mass of the wooden log is, density of the wooden log is rho suffix m. M for, not m, W. Rho suffix W. W for wooden. Okay, wood. Rho suffix W. Then that pi by 4 d square into L volume multiplied by the density rho W is equal to what? Mass of the wooden log multiplied by G is equal to weight of the wooden log. Then weight of the wooden log is equal to that upward thrust or the buoyant force. So you write this way, pi by 4 d square L into rho suffix m is equal to rho into V into G. Rho into V into G. Okay. So here, if density of the liquid, G from both sides are cancelled. Okay. If density of the liquid is known, density of the wooden log is known, then you can calculate from here V. If V is known, then you can calculate the height or the length or the portion of the wooden log which is beneath the free surface of water. Means only one unknown will be there, everything will be known, only one unknown will be there. You can calculate from here that unknown. Okay. If the wooden log is of rectangular cross section, then that problem will be easier to solve. In case of cylindrical, it will be somewhat complicated. Anyway, everything will involve your geometry. If geometry is complicated, the problem will be somewhat difficult to solve. Otherwise, any other things related to such problems are very easy to apply. Means theory involved in Archemedes Principle is so simple. Only complicated thing is the geometry of the body. If geometry is complicated, solution of the problem will be difficult. Okay? Anyway, so what is the ultimate conclusion? No, I am not concluding anything. The principle which you want to use for any problem related to Archimedes principle is that weight of the body is equal to volume displaced, weight of the liquid or fluid. It's better to say fluid. Weight of the fluid displaced by the body. That means when a body is surrounded by air, I am standing here and I am surrounded by air. That means there is some reduction of weight of my body due to the presence of air. Okay, how much is the reduction? My body has certain volume, so that volume multiplied by the density of the water air, normally it is taken as 1.2 to 3 kg per cubic meter. Density of air, okay, 1.2 to 3 kg per cubic meter. So I have some volume, so that volume multiplied by the density of the air, that is equal to mass of air, multiplied by G, that is equal to weight of the air. So that weight is acting in the vertically upward direction on my body. So if you want to measure my weight by using any device, there will be some reduction in weight due to the presence of surrounding air. Okay. Okay, I think this is sufficient. for this principle. Still, if you have any queries, you can ask me. Just write in the comment box. And in this channel, I want to mention again, in this channel, means in this YouTube channel, you will get 3 subjects altogether, which are taught in the first year, means first semester and second semester of engineering courses in India. What are those subjects? Engineering mechanics, engineering thermodynamics, and fluid mechanics. All the video lectures will be given in same YouTube channel, Triple SD Sciences. Okay. Okay, thank you.